Hello and welcome to another one of Dee's ADD videos. Today we're going to be looking at the concept of Riemann sums and how they're used to evaluate definite integrals. Whenever we're doing a definite integral, we're taking the area approximated by rectangles and looking at them as the number of rectangles approach infinity. And what we're going to be doing is we're going to be converting the definite integral, when they have bounds, it's a definite integral, which represents the area under a curve of f of x dx, into a limit as n approaches infinity of the summation of the product of the length times the width of the rectangles. So the length is your f of xi and the width is your delta x. How do we calculate these? Well, your delta x is going to be b minus a over n, where b is your larger bound of the region, a is the smaller bound, n is the number of rectangles. In this case, n stays n, doesn't become a number. So then xi is equal to a plus delta xi, where a is the starting point, the lower bound. Delta x we just calculated, and I stays I. Essentially what you're doing is you're taking the integral and evaluating it as a limit using the area of these rectangles. Like I said, this is the length, this is the width. Length times width is the area of a rectangle, to approximate the area of the region. And what we're doing is we're looking at the number of rectangles approaching that infinite. It was finite. We were using 3 rectangles, 4, 5, 6 rectangles, whatever they decided. But now we're approaching infinite number of rectangles when we use the limit. So you're going to have to memorize these equations, and what I suggest you do is that you put on one side the summation of I from 1 to n of I equals, and then on the other side you put what it equals. Same thing for I squared, I cubed. This is the summation from 1 to n of a constant, is n times that constant. If I have a constant times some term with an I in it, you can pull out that constant that has no i's. It could have an n but no i's in front of the summation. If you got 2 I terms being added and they're both summed, you can sum them individually. And if they're subtracted, you can subtract them individually. All right, so no cards, 5 minutes a day, every other day, you'll have it within 3 or 4 days. So what are the steps that we're going to be doing when dealing with this type of problem? Well, the first thing you got to do is you got to figure out what delta x is. So delta x is going to be the b minus the a over the n, where b is the upper bound of our region, a is the lower x value of our region, and n stays n in these problems. Step 2 is to figure out what xi is, and xi is going to be the starting point, a, depending on what your rectangle endpoint you're using, left, right, or midpoint. A will differ. And then plus delta xi, and we calculated delta x before, I stays I. Next thing we do is we use this formula for the limit of the summation of f of xi times delta x. And what you're going to do is you're going to plug in that xi you just calculated in for every x of your function. After you do that, you're going to multiply by delta x, and I want you to recognize that delta x is being plugged into step 2 and 3. Then what you're going to need to do is you're going to need to evaluate the limit using formulas that you should memorize. What I recommend you do for these things is I recommend you do some note cards and you check them out every other day, like I said before. The more you use them, the more familiar you will become with them, and the more you won't even have to think about, oh, what is I? It'll just come naturally to you. But note cards helps you, making the note cards helps you memorize all this stuff, and it will become more apparent how to work these problems once you see it actually being done, all right? So check out the example videos. As always, pause the example videos, try the problem, then check out the solution. If it matches, good. If it doesn't, then watch the video and see where you made a mistake, or where I made a mistake. As always, practice, practice, practice. Thanks for watching. Have a great day.